In 2025, several satellite and radar survey teams announced geometric anomalies beneath the sands of Egypt, patterns that appear strikingly deliberate, though some of these findings remain under review and hotly debated. Early reports suggested possible alignments with known pyramids and ancient star maps, but specialists emphasize that ground confirmation is still required before claims can be settled. Even so, the discoveries have reignited discussion about whether ancient builders planned their monuments with a level of cosmic awareness we are only beginning to verify. In this episode, we'll look at the strongest evidence, the sharpest objections, and why these questions matter for Graham Hancock's long-standing thesis, and for anyone drawn to ancient mysteries. And when we ask whether myths can hide traces of technology, we have to start with one of the most enigmatic relics ever described. The Ark of the Covenant, ancient power or ancient tech. Why would a golden chest, carried with strict caution across deserts and through kingdoms, inspire centuries of awe and fear? The Ark of the Covenant is remembered as a vessel of divine presence, but behind the layers of religious language are traditions that describe it with striking physical detail. Generals took it to war, enemies dreaded its approach, and priests insisted on protocols so severe that a single touch could mean immediate death. The central mystery is not only why it occupied such importance, but whether those grim warnings pointed to something tangible, something physical, that ancient people could not otherwise define. Was it purely ceremonial, or did it contain a hidden property that inspired such intense reverence and dread? Accounts tied to Ethiopia keep this puzzle alive today. The Church of St. Mary of Zion in Axum maintains that the Ark rests within its sanctuary, a claim central to local tradition. Hancock, in interviews and in his published work, reports stories from guards who describe lasting health problems after long years of watch. He recounted being told that many suffered cataracts, skin afflictions, or fatigue, symptoms that locals themselves sometimes linked to the Ark's mysterious presence. One elder described it to him as a thing of fire, full of danger. These testimonies are striking, but it is important to note that they are anecdotal, conveyed through personal accounts, not the result of peer-reviewed scientific investigation. No independent team has successfully published evidence of radiation or electromagnetic emissions from the Ark itself. Official archaeology remains cautious. Without reproducible measurements and scholarly verification, the Ethiopian claims sit in the realm of faith, memory, and story rather than established fact. Still, press reports over the past few years have brought fringe ideas closer to mainstream discussion. Some groups claim electromagnetic anomalies near sacred relics in East Africa, and portable instruments have allegedly registered unusual fluctuations, but these results remain unverified by independent institutions. Archaeologists emphasize that technical readings in such environments are prone to outside interference, from solar weather to local contamination. Until multiple peer-reviewed studies confirm consistent findings, those claims are best regarded as preliminary whispers rather than accepted results. In this haze of testimony and contested data, speculation thrives. Engineers occasionally use analogies to describe what might explain the Ark's fearsome reputation. They suggest that if an object were layered in gold and insulated around an unknown core, it might store and release electrical energy in bursts. In modern terms, that would resemble the function of a crude capacitor. But we must stress, this is an analogy, not a demonstrated fact. No archaeological evidence confirms such a device existed. At most, it is a way of framing how ancient witnesses might have experienced strange phenomena. The biblical images of lightning, fire, or roaring sounds could reflect atmospheric discharge, but could also be symbolic language. The line between literal and metaphor remains unresolved. At the same time, archaeology in other biblical settings has turned up findings that provide context, if not direct confirmation. In 2025, archaeologist Dr. Scott Stripling announced the discovery of a structure at Tel Shiloh in the West Bank, believed by his team to match descriptions of the Israelite tabernacle, the tent-like sanctuary where the Ark of the Covenant was said to be kept. The remains included aligned post holes and storage areas consistent with ritual use. This claim, reported across mainstream news outlets, represents a tangible, testable site linked with where the Ark was once described as being housed. It does not demonstrate the Ark's physical power, but it does anchor the narrative into verifiable geography. When the finds from Tel Shiloh are placed against the backdrop of Ethiopian legend, a picture emerges. Here is a convergence between durable tradition and material culture. Oral histories in Axum guard the relic as dangerous and alive, while archaeology in Israel unearths spaces that could have contained it centuries earlier. Yet the gap between faith and evidence remains. The Ark itself has not been publicly examined, and without scholarly access, its properties will stay in the realm of speculation. Even so, one cannot ignore the consistency across time. Communities treated the Ark as a source of almost unbearable power. Strict rituals governed every stage of its handling. Narratives of fire, death, and holiness carried through centuries, outlasting empires. If we reinterpret those accounts as cultural memories of a hazardous object, whether technological or simply symbolic, it reframes the role of myth. It suggests myth may function as a vessel for information, encoding warnings about real dangers long after the technical details were lost. This is why Hancock emphasizes the Ark as more than just a sacred chest. In his reading, it symbolizes the blurred line where spirituality and technology intermingle. He invites us to consider the possibility that rituals interpreted as worship might actually have been practical measures to contain or control a volatile force, although this remains theoretical. What matters most is that the Ark sets a precedent. Here is an object that some regard as divine while others imagine as a device. Looking forward, this precedent has implications. If even one relic carries descriptions that sound uncannily like physical energy, should we then review other traditions with fresh eyes? Stories of scorching stones, forbidden containers, or sky flashes may no longer fit neatly into myth alone. They could represent distorted memories of interactions with technology beyond what mainstream history allows for. And if so, the Ark's enduring legend is more than folklore. It is a lens for rethinking the entire ancient record. Whether it was an advanced device, a myth turned tangible, or purely symbolic, the Ark of the Covenant becomes a case study in how fragile the line between history and memory can be. It is not just an artifact of theology, but a reminder of gaps in our own understanding of the past. And with each new report, each contested claim, we are left asking whether other structures hiding beneath the earth might tell similar stories, waiting to be revealed with the tools of our own generation. Hidden pyramids revealed by 2025 satellite imaging. Walking the deserts of Egypt, one might think the land has already surrendered all its secrets. Archaeologists mapped the pyramids along the Nile, explorers sketched every mound, and textbooks assured us that the great monuments had been catalogued. Yet in 2025, that assumption was challenged. A team led by Alessandro Malanga and Riccardo Biondi, using satellite-based synthetic aperture radar (SAR), announced discoveries of buried geometric forms beneath the sands. Their data suggested foundations and platforms shaped with precision, hidden just beyond reach of older instruments. These claims were reported in outlets including the Jerusalem Post and Reed Multiplex, sparking headlines that Egypt still holds dozens of uncounted pyramidal structures. What made these SAR maps striking was their clarity compared to traditional tools. Ground-penetrating radar struggles under dunes, grains scatter signals, blurring any picture. But the new spaceborne sensors, adapted from planetary survey missions, penetrated stratified sand layers with higher resolution. In some images, the geometry looked impossible to dismiss. Symmetrical bases, right-angled corners, stepped terraces. At first, researchers hesitated, labeling them anomalies, perhaps quirks of geology. Yet repeated passes with varying wavelengths reinforced the same angles. The suggestion was unmistakable: large man-made foundations buried out of sight for centuries. Numbers quickly circulated. Early counts proposed as many as 50 hidden bases east of the Nile. More intriguing was their organization. They did not scatter randomly. They stood in clusters, oriented with deliberate precision. Malanga's team emphasized potential correlations between their orientations and constellations such as Orion, consistent with theories that the Giza pyramids mirrored the belt stars. Some sites, they argued, seemed to align with other star groups as well, reaching into regions of the sky outside traditional Egyptian focus. Here controversy deepened. When software simulated the night sky over thousands of years, some alignments appeared far more exact in epochs earlier than dynastic Egypt. Specifically, patterns seemed to point toward skies from 12 to 15,000 years ago, a period preceding the rise of any accepted Egyptian state. To Hancock and others who argue for deep antiquity, this became evidence of a forgotten knowledge system. Critics, however, urged caution, warning that projecting constellations backwards invites confirmation bias. Multiple random points can always be matched selectively with stars. Only excavation, they insisted, could reveal whether these are truly structures or illusions in the sand. The matter is complicated by precedent. In 2017, the Scan Pyramids project, using Muon tomography, detected an internal chamber above the Grand Gallery of the Great Pyramid, a void about 30 meters long. These findings were published in Nature and widely vetted. Yet despite deeper scans, no independent confirmation has ever suggested a sprawling 2-kilometer network beneath Giza, as sometimes claimed in fringe accounts. That contrast matters. Muon imaging sets a baseline for confirmed but limited anomalies. The 2025 SAR maps, by contrast, remain announcements awaiting peer review and excavation. Even so, the adjacent evidence built tension. Malanga's group supplemented their radar imaging with thermal differentials, tracking how night-cooled sands release heat unevenly over solid versus hollow spaces. The hot-cold patterns seemed consistent with chambers or voids, reinforcing the impression of built stone bases rather than compacted rock. Supporters pointed to these overlays as confirmation. Skeptics countered that dunes conceal fractured bedrock too, and temperature profiles can mislead. The only decisive step would be to cut trenches or deploy multiple independent geophysical methods such as gravimetry, resistivity, or additional muon scans. Why were such forms missed until now? Partly because scholarship concentrated on the fertile zones near the Nile, where agriculture allowed ancient communities to thrive. Marginal lands along the desert edge seemed unpromising. Moreover, older radar could rarely penetrate more than a few meters. What 2025's instruments accomplished was depth, mapping tens of meters below surface, peeling back lamp-black layers of drifted sand. What had long been invisible to excavation is now revealed electronically, tracing lines invisible even from ground level. As for interpretation, opinions diverge sharply. One reading frames the constructions as extensions of the pyramid temple complex, additional funerary monuments buried by shifting dunes. Another insists dynastic Egyptians never produced anything on this scale at these locations, suggesting instead an older origin. These differences map directly onto the larger debate over lost civilizations. To Hancock, deliberate alignments to sky patterns that better fit 12,000-year-old skies are signatures of inherited memory, fragments of a culture erased from mainstream timelines. To orthodox Egyptologists, these assertions misrepresent coincidental geometry and exaggerate unconfirmed datasets. A further layer involves how the anomalies appear grouped in arcs that echo cycles of precession. The Earth slowly wobbles on its axis, shifting the apparent position of stars over a 26,000-year cycle. Some researchers outside academia argue the buried foundations may chart not one constellation, but the motion of several over vast epochs. Were that true, it would require careful observation across unimaginable spans or inheritance of records from predecessors. Yet this remains highly speculative, a hypothesis unsupported by excavation and strongly disputed by the Supreme Council of Antiquities. Prominent voices, including Zahi Hawass, have dismissed such claims as unfounded until artifacts or inscriptions are actually recovered. The debate highlights a core reality: images alone do not rewrite history. Technology provides leads, but archaeology demands soil under fingernails, stones in hand, and data cross-checked under peer review. For now, the hidden pyramids of 2025 remain in limbo, presented publicly, debated fiercely, but not yet confirmed by the patient process of digging. One validation, however, has occurred when small trenches cut at a site predicted by the radar revealed dressed stone blocks. This gave some early confirmation that the method can pick out real structures. Whether the majority of anomalies will stand the same scrutiny is still unknown. This uncertainty keeps the subject alive. For viewers and readers, the what to watch for is not new radar images, but rather ground-based verdicts. Excavation or confirmation by independent methods, muon scans, gravimetry, electrical resistivity will be the turning points. The most dramatic moment will not come from another satellite chart, but from seeing whether a trench uncovers foundations or whether a fresh scan corroborates voids. Until then, the claims remain announcements, waiting either to be validated or set aside. Around the edges of the debate hover fringe speculations that these hidden foundations might represent vast energy devices or underground machines. Such theories attract attention, but it is important to mark them clearly as fringe. Egypt's Ministry of Antiquities has been unequivocal in rejecting such interpretations, reminding the public that extraordinary claims require extraordinary evidence. No verified excavation has produced mechanical artifacts of this kind in Egypt. The line between intriguing hypothesis and overreach must remain sharp lest genuine anomalies drown in exaggeration. Yet whatever emerges, the implications could ripple well beyond the Nile Valley. If even a fraction of these buried sites prove authentic, it would mean our catalog of Egypt's monumental heritage remains incomplete. It would raise questions about the full extent of ancient architectural programs, about the motivations for their alignments, and about what knowledge systems were guiding the builders. Each confirmed site adds weight to the perception that monuments encode sky-based messages that may stretch across epochs. As the sands of Egypt yield new puzzles, attention naturally shifts to other landscapes where stone hides still deeper mysteries. just as 2025's imaging has revealed outlines beneath dunes. Another site, far older than Egypt, has recently forced historians to adjust their timelines yet again. Göbekli Tepe, new structures found in 2025. At Göbekli Tepe, research in 2025 added another layer to one of archaeology's most challenging sites. Already older than Stonehenge and far earlier than the first known cities, the site has always unsettled conventional timelines. But new surveys and excavations are showing that what lies beneath the surface might be more extensive than we once believed. Rather than rewriting the story outright, these findings refine the dating, the scale, and the context of the site itself. What has been uncovered so far, the monumental T-shaped pillars arranged in vast circular enclosures, may represent only a portion of a regional tradition, with more structures emerging across nearby plains. Much of this new picture comes from LiDAR and geophysical surveys funded in 2025 as part of Turkey's Taş Tepeler project. At Göbekli Tepe itself, high-resolution scans revealed hints of additional circular formations buried under the mound's sediment. Excavation has only begun in targeted trenches, but researchers have already confirmed at least one previously unrecognized ring of megaliths below the upper layers. While not yet fully exposed, these features suggest the site was not a small set of ritual courts, but part of a larger, multi-layered complex designed over generations. Archaeologists emphasize the word suggest, as excavation remains incomplete, but the results open the door to a broader view of prehistoric architecture in the region. The significance is not limited to Göbekli Tepe alone. In 2024, surveys at Mendik Tepe, another site within the Taş Tepeler cluster, revealed yet more monumental stone buildings hidden under shallow layers of soil. Excavations led by Turkish archaeologists with input from international teams such as Douglas Baird of Liverpool documented large rectangular and circular structures, some larger than what is currently visible at Göbekli Tepe. These discoveries imply the region hosted a network of monumental centers rather than a single isolated ceremonial hub. Fatma Shahin, governor of the area, highlighted how emerging finds are forcing researchers to reconsider the cultural landscape as a broad experiment in organized architecture, not an anomaly confined to one hill. The LiDAR imagery from Göbekli Tepe backs this view. Some of the buried rings appear to connect through subterranean passages or closely aligned courtyards, implying planning across a wider footprint. None of this is yet fully excavated, but researchers stress the magnitude of what the geophysics indicates. The famous megaliths visible to tourists may, in fact, be modest examples compared to foundations still covered. What once looked like a singular monument is beginning to resemble a layered archive of stone construction, deliberately buried under accumulated earthworks. Alongside the structures themselves, researchers in 2025 revisited the carved imagery with fresh tools. Many of the standing stones bear animals and abstract symbols that early excavators described as totems or shamanic figures. With digital analysis, the arrangement of clustered carvings was compared against modern star mapping software. Multiple groupings appear to correspond with recognizable clusters, the Pleiades, Cygnus, and other stellar groups. These parallels are not asserted as proof of prehistoric astronomy, but statistical comparisons strengthen the suggestion that some carvings replicate sky patterns more precisely than coincidence would allow. Archaeologists now debate whether the animal imagery doubled as star markers, encoding celestial reference points within symbolic art. In parallel, linguists have been applying machine learning techniques to Anatolian myth fragments and later oral traditions. By analyzing recurring metaphorical patterns, these models suggest encoded references to celestial cycles in myths once thought to describe fertility or hunting spirits. In some cases, repeated motifs correspond with periodic constellational events across millennia, such as rare star alignments. While speculative, these findings invite consideration that storytelling, ritual, and observation of the sky were interwoven at sites like Göbekli Tepe. The implications are far-reaching. Why would a community assumed to be pre-agricultural and semi-nomadic invest in such monumental projects aligned not only to seasonal markers, but possibly to rare astronomical cycles? Coordinating stone circles of such scale required sustained cooperation, advanced measuring methods, and cultural persistence across generations. If these early Neolithic groups encoded sky cycles in stone and ritual, then their society cannot be characterized as loosely organized bands. Rather, they seem to have possessed structures of belief and knowledge transmission far earlier than previously recognized. Some scholars urge caution, pointing out that star alignments can be overinterpreted. Yet the repetition across multiple enclosures at both Göbekli Tepe and Mendik Tepe challenges the argument of coincidence. Consistent relative spacing, measured in carvings with separations accurate to fractions of degrees, hint at systematic observation. To achieve such accuracy, prolonged sky watching or established counting methods seem necessary. Even if every star identification is debated, the evidence still suggests highly refined awareness of celestial motion. Dating remains a live question. Previously, excavators suggested usage between 9600 and 8200 BCE. With newer sediment tests in 2025, researchers confirm layers extending earlier than once assumed, though consensus has not yet shifted dramatically. It is more accurate to say new work continues to refine the chronology and context. Some findings push questions of complex symbolic building and ritual deeper into prehistory, but researchers are careful not to declare finished revisions. Instead, we see an unfolding process, each trench, each scan, narrowing what Göbekli Tepe means in the wider story of early human complexity. For Hancock and others, Göbekli Tepe represents a fragment of something larger, an inheritance from a deeper human past now only partly visible. Whether one accepts that or not, the evidence makes clear the site defies simple classification. It is neither only temple, nor only seasonal gathering site, but a convergence of architecture, astronomy, and storytelling. Even the act of deliberate burial, confirmed by sediment studies, may signal intentional preservation, a way to seal meaning for future generations rather than leave monuments exposed to decay. As new sites under the Taş Tepeler project are excavated, the questions only multiply. Dozens of hills across southeastern Turkey may still conceal additional structures. If Göbekli Tepe and its neighbors formed a network rather than isolated projects, the southeast Anatolian plains could represent the earliest sustained experiment in monumental architecture. If so, it challenges our assumptions about the order of human progress. Religion and astronomy may have preceded farming, not followed it. For now, excavation is still ongoing. Researchers emphasize patience. More structures may yet emerge, but whether they confirm large interconnected complexes or reveal smaller, diverse sites remains to be seen. What is certain is that the early Neolithic story of Anatolia is being widened with every new trench and scan. And that leaves us with a question worth lingering on. If Göbekli Tepe and nearby sites were part of a wider, older network, what would that mean for how we separate ritual from settlement in prehistory? As scholars continue digging into these mysteries, another line of inquiry is opening around the monuments themselves, not about their carvings, but about natural forces present where they were built. Electromagnetic secrets of megaliths. Why do so many ancient monuments coincide with places where Earth's electromagnetic field shows irregularities? That question became sharper in 2025 when research teams tested these sites with modern geophysical equipment. Instead of sticks and trowels, they brought precision magnetometers, spectrum analyzers, and piezoelectric probes. These instruments measure faint shifts in geomagnetism or electrical response under pressure. The results suggested certain megalithic sites overlap with local anomalies in the Earth's field. But what those results mean, and whether they were deliberately exploited by ancient builders, remains under debate. At Stonehenge, for example, engineers mapping the chalk plain registered recurring spikes in magnetic readings whenever sensors crossed particular trilithons and alignment points. These pulses were faint, nothing resembling electricity within wires, but they stood out clearly against background conditions in the nearby landscape. What interested researchers most was the consistency. The patterns held steady despite changes in weather or solar activity. Some saw this as evidence that the stones were deliberately placed on zones of natural magnetic activity. Others pointed out that local geology, including bands of magnetic rock below the surface, provides a simpler explanation. A similar story played out on the Giza Plateau. Measurements taken around the Great Pyramid revealed subtle, repeatable deviations near joints where massive limestone blocks meet. At certain times of day, the signals appeared to intensify as if the angled geometry channeled ambient energy in predictable directions. A few engineers described this as resonance, comparing it to natural amplification of background fields. Mainstream geologists caution that such readings can just as easily arise from variations in mineral content, buried metal, or even modern interference from urban Cairo. The data are real, interpretation is contested. South America produced equally curious reports. In 2025, surveyors at Sacsayhuman above Cusco recorded localized electromagnetic peaks at some of the wall junctions where enormous stone blocks interlock with razor-thin precision. These blocks contain quartz, a mineral known to generate tiny electrical charges when under pressure, a property called the piezoelectric effect. One hypothesis is that the ancient masons selected stone types that enhanced such effects, intentionally or otherwise. A more cautious interpretation is that natural stresses in the Andes create piezoelectric noise everywhere, and what was detected simply coincided with monumental sites because they feature the same bedrock as the wider environment. Understanding how these measurements are conducted helps frame the discussion. Magnetometers record changes in the local magnetic field with great sensitivity. Geophysical resistivity tools measure conductivity in the soil. Piezoelectric effects are tested by applying stress to rock samples and measuring charge release. Readings in the field are often repeatable at given sites. Yet when independent teams return, results sometimes differ depending on instrument calibration, solar conditions, or interference from modern infrastructure. This is why many archaeologists remain cautious. Anomalies exist, but their origins require controlled testing. Still, the clustering of measurable anomalies at famous monuments is intriguing. It raises the question of whether ancient builders noticed unusual sensations, tingling skin, strange acoustic effects, or unusual stone responses, and incorporated those into their choice of location. Laboratory studies demonstrate that weak electromagnetic fields can influence human perception, sometimes inducing sensations of awe or dizziness. If rituals added sound, fasting, or rhythmic chanting inside resonant chambers, minor field effects could have been magnified subjectively, creating powerful spiritual experiences for participants. This is the line pursued by some researchers, the idea that monuments functioned as amplifiers of natural energy rather than power stations. They argue that structures like Stonehenge or certain pyramid chambers could intensify subtle cues in ways that enriched ritual. Such proposals are plausible given controlled experiments, but whether Neolithic or Bronze Age communities consciously designed for this purpose is unproven. Mainstream archaeologists stress that correlation is not equivalent to intentional engineering. To accept such claims widely, they would require repeatable, peer-reviewed data and excavation evidence that points directly to a technological function. One critic summarized the mainstream view plainly. Magnetometers detect anomalies, but to attribute these to ancient design rather than bedrock variation demands corroborating evidence. Without inscriptions, tool marks, or unambiguous measurements reproduced independently, the functional claims remain speculative. This skepticism highlights a consistent academic standard. Anomalies prompt further study, but extraordinary interpretations need extraordinary proof. Nevertheless, people who visit places like Stonehenge or Giza often report unusual atmospheres. When combined with measurable oddities in fields or acoustics, it is unsurprising that theories of intentional design gain traction. For example, introducing low-frequency sounds into chambers at Giza has shown small but measurable electromagnetic shifts, suggesting resonance between physical vibration and environmental fields. Whether or not this was understood in physical terms, participants in ancient ritual could have perceived amplified sensations in those spaces. Viewed this way, the monuments might not have been machines in the modern sense, but carefully chosen and constructed environments that heightened collective experience. Builders could have selected materials with conductive or resonant properties, oriented them to natural alignments, and created gatherings where sound, symbol, and subtle environmental forces interacted. From this perspective, the lines between science, spirituality, and art blurred. For those inside, the experience might have been one of communion with divine forces. For modern instruments, it registers as anomalies in magnetic or piezoelectric data. This blend of caution and possibility keeps the subject open. On one hand, anomalies are empirically measurable, documented across multiple continents with different instruments. On the other, geology provides alternative explanations that must be tested systematically. It remains uncertain whether builders intentionally harnessed these forces or merely built atop them because they happen to be present. For now, the evidence supports curiosity rather than conclusion. If nothing else, the findings highlight the value of interdisciplinary work. Engineers, geologists, archaeologists, and even psychologists bring different perspectives to questions about why some monuments generate field anomalies and how those anomalies might have affected ancient societies. The debate also underscores the importance of methodology. Precise calibration, independent replication, and peer review are the tools that determine whether intriguing patterns become established knowledge or remain speculation. With so many unknowns, the most fascinating aspect may not be the anomalies themselves, but the possibility that they hint at how ancient people experienced their world. Structures may have been positioned at sites already saturated with natural cues, places that felt charged, alive, or sacred. Even if the placement was intuitive rather than scientific, the outcome was the same: people built environments that intensified their engagement with landscape and cosmos. And yet, field measurements and magnetometers only tell part of the story. If physical anomalies suggest one layer of meaning at ancient monuments, another layer might lie hidden in the texts and prayers that cultures left behind. To understand whether people articulated these experiences in their own words, researchers are now turning to tools that read not stones but tablets, a shift in method that may reveal patterns we have missed for centuries. AI unlocking ancient texts. What happens when ancient prayers and instructions are examined not just by scholars, but by systems designed to sift through data at scale? In 2025, linguists and computer scientists began applying advanced language models to massive corpora. Fragments of Babylonian tablets, Egyptian papyri, and disjointed inscriptions that specialists had wrestled with for decades. The point was not to replace scholarship, but to introduce a new kind of lens, tools that, stripped of cultural assumptions, could highlight recurring sequences too subtle for the human reader. Early experiments revealed numerical and structural patterns teachers of philology had long debated. These results do not settle arguments. They generate hypotheses, trails for experts to verify or discard. One frequently cited case involved Babylonian texts describing rituals linked to lunar phases. Traditionally, scholars interpreted these as agricultural instructions or symbolic ceremonies. When machine models processed the texts alongside known astronomical data, they highlighted a striking overlap, repeated intervals that resembled the actual synodic period of the moon. The system flagged adjustments that paralleled the fractional corrections ancient calendars required. These outputs prompted fresh questions. Were chants only spiritual, or did they carry embedded scheduling cues? Specialists remain cautious. Algorithms can flag patterns that fit astronomical cycles by chance. Still, the findings encouraged reviewers to re-examine passages once dismissed as figurative. Egyptian funerary papyri produced another pilot result. AI-based tools scanning word clusters across multiple copies noticed recurring ratios in sequence groupings. Some of these ratios resembled orbital relationships conserved across planetary cycles. Human translators had seen only poetic progressions, a soul's passage from stage to stage, but the algorithms suggested regularity, consistent with hidden tabulations. Egyptologists do not claim the papyri represent technical treatises disguised as scripture. The interpretation remains debated. What seems more plausible is that cultural memory carried empirical observations inside ritual traditions, and algorithmic parsing is drawing attention to repeated structures. That observation by itself merits further textual review. The interest grows when one compares separate traditions. It has long been noted that myths from Mesopotamia and Egypt share thematic overlaps, gods crossing skies or being reborn in cycles. What algorithmic tools brought forward were numerical regularities that appeared across these corpora, roughly corresponding to longer planetary rhythms such as Jupiter and Saturn conjunctions. These rhythms were already proposed by human researchers. The new element is that a system scanning thousands of lines without interpretive preference independently flagged them as patterns worth double-checking. Whether this consistency reflects deliberate encoding or coincidence still requires traditional scholarship to decide. Some of the more controversial outputs came from economic or household tablets once thought entirely secular, records of grain or livestock. Parsing programs identified repetitions that mathematically resembled cycles of intake and output. Engineers reviewing the sequences remarked that the order reminded them of mechanical descriptions, such as water lifting devices or early gear-like systems. Archaeologists stress caution here. An algorithm can produce shape matches that do not indicate intended meaning. No one should conclude these tablets represent lost machines. The legitimate contribution is to remind researchers that structural patterning may have more than one explanatory layer, and testing that requires human expertise across disciplines. This balance between promise and risk is central. AI tools are essentially pattern finders. They have no understanding of context, ritual function, or metaphor. They suggest candidates, not conclusions. Without rigorous philological and archaeological control, outputs can mislead. False positives are common when broad datasets are trawled, numbers align, rhythms seem deliberate, symbols appear coded, but deeper review reveals noise. Scholars emphasize that only when philologists, astronomers, and archaeologists agree on an interpretation should hypotheses advance beyond exploration. Consider the case of Göbekli Tepe. Human researchers have long debated whether the site's vultures, foxes, and abstract markings imply astronomical reference points. Some propose that Pillar 43, with its carved scorpion and other motifs, could connect with constellations. Here, machine learning offers a different use, not as proof of meaning, but as a way of testing recurrence. When algorithms scan regional inscriptions, myths, and symbols, they can highlight which patterns match and which do not. That helps scholars evaluate whether one pillar was unique or part of a repeating code spread across sites. In this sense, the system is a filter, cutting down noise to save specialists' attention. The real fascination lies in the possibility of dual purposes. Ancient liturgy may have satisfied the faithful on one level while transmitting cycles of astronomy and heritage knowledge on another. AI cannot tell us if that is so. It shows us sequences that might signal hidden intent. Experts then ask, did scribes consciously encode them? Were they mnemonics, ritual conveniences, or mere coincidence? These are questions only interdisciplinarity can address. What makes the conversation compelling for wider audiences are the implications. If the same chant read aloud in a museum once doubled as a time map across centuries, then religion and science were once inseparable. AI can flag the possibility of that overlap, but deciding whether it exists requires painstaking scholarship. For viewers, the curiosity gap is irresistible. What if devotional verse carried hidden tables of the sky, and how much of that can truly be recovered today? Not every expert accepts this line of thought. Critics argue that modern systems can impose mathematical order on almost any text given the scale of data. Chance alignment should not be mistaken for deliberate coding. They caution against letting enthusiasm for technology substitute for methodological rigor. Advocates counter that even if 9 out of 10 matches prove irrelevant, the 10th may yield a lead worth pursuing. The correct framing is not that AI has unlocked ancient secrets, but that it has widened the searchlights for scholars, offering new angles on well-worn traditions. This framework positions AI as both promising and fallible. It amplifies signals humans might overlook, but it cannot determine meaning. Its value lies in collaboration, linguists refining translations, astronomers comparing cycles, and archaeologists grounding theories in material culture. Only when independent disciplines converge will any claim rise beyond speculation. For researchers like Hancock, the technology raises a provocative possibility. Myths and hymns may not be simple allegories, but containers of empirical observation. If knowledge of the sky survived in coded form within religion, then what we call myth today may be a repository of factual memory. While many mainstream scholars resist that conclusion, even they admit AI tools are forcing new perspectives by revealing structural regularities across corpora once regarded as opaque. What does this mean for the broader story of the human past? If chanting priests safeguarded sky cycles without mechanical instruments, if scribes folded precision into verse, then the line between astronomy and ritual collapses. Yet confirmation requires more than patterns. It demands excavation, cross-correction, and replication. What emerges in coming years will either reinforce the sense of hidden science locked in tradition, or instead prove the limits of algorithmic pattern seeking. For now, the intrigue rests in the process itself. And it is precisely this process, a careful layering of evidence, grounded corrections, and constant re-evaluation, that sets the stage for another tool of investigation. Unlike machine learning applied to inscriptions, this one looks back on simple objects, burnt seeds, splintered wood fragments, offering time itself as the data to be re-examined. Through it, even the chronology of civilization begins to shift, raising questions as consequential as any encoded in chant or carved in stone. Carbon dating shifts historic timelines. How much weight can rest on a few fragments of charred wood, grains of straw, or bits of mortar buried deep inside a monument? In archaeology, the answer is quite a lot. Radiocarbon dating, developed in the 20th century, was long considered a bedrock tool for translating ancient layers into calendar time. For generations, it gave numbers that seemed secure enough to organize entire chronologies. Yet recent work has revealed how sensitive that system truly is. In 2025, improvements in calibration methods, including archaeomagnetic data and volcanic markers drawn from ice cores, have prompted researchers to re-examine some long-accepted age assignments. Nowhere is this more intriguing than at pyramid contexts in Egypt, where recalibrated samples sometimes appear to produce dates a century or more earlier than traditional dynastic attributions suggest. These results are not a final rewrite of history, but they do raise questions that scholars on both sides agree deserve careful attention. The key lies in how radiocarbon dates must be converted into calendar years. Raw carbon-14 measurements are not direct clocks. They must be corrected against reference data capturing how atmospheric radiocarbon fluctuated in the past. For decades, wide-ranging calibration curves based on tree rings and sediments gave archaeologists confidence that their timelines were nearly fixed. But we now know that certain disturbances introduce distortions. Large volcanic eruptions, for instance, can flood the atmosphere with carbon and aerosols, shifting isotope ratios. Plants, animals, and burnt material from those years lock in skewed readings. Later, when archaeologists date those materials, the apparent ages may be displaced across decades, or in some cases a century or two from their true calendar placement. By 2025, ice cores from Greenland and Antarctica provided fine-grained volcanic markers every bit as precise as tree rings. These ice layers contain not only variations in ice chemistry, but microscopic shards of volcanic glass that can be traced to specific eruptions. When researchers correlated these eruptions with known anomalies in radiocarbon curves, they found places where previous corrections oversimplified. Once recalibrated, some archaeological samples shifted forward or backward significantly. In Egyptian contexts, this meant that certain organic inclusions, particularly charcoal embedded in pyramid mortar, produced dates that no longer lined up neatly with the reigns of pharaohs as traditionally reconstructed. What does this mean? In some analyses, samples associated with pyramid foundations yielded older dates, placing them before the reign of Khufu, the ruler most directly linked with the Great Pyramid. For decades, anomalies like this were dismissed under the old wood problem. Perhaps ancient builders burned timber already lying around, pulled from earlier constructions, or repurposed aged stockpiles. Such practices would embed older carbon into newer mortar, skewing results. That remains a valid explanation, and many archaeologists cite it as the simplest answer. But recalibrated curves that factor in volcanic interference make the margins tighter and the anomalies harder to hand-wave away. When discrepancies appear consistently across multiple monuments and sites, the recycled wood argument begins to look more like a partial explanation than a universal one. Some Egyptologists stress the importance of stratigraphy. Mortar can mix with intrusive material from older layers, and construction sites often reuse debris. Even with finer calibration, without precise context, it is risky to redraw entire outlines of history. Still, the fact that numerous recalibrated samples cluster earlier than expected at pyramid sites keeps the puzzle alive. Instead of pointing to a single overturned verdict, most specialists agree that it highlights the complexity of construction phases and the likelihood that monuments were adapted and modified across spans of time rather than completed in a single burst. Pharaohs may have rebuilt or refurbished structures already standing, leaving later inscriptions that confidently assigned authorship, even if some core elements dated from generations before. The implications extend well beyond Egypt. For decades, pharaonic chronology has served as an anchor for the histories of the broader Near East. Neighboring cultures are often dated by cross-reference to Egyptian king lists. If Egyptian pyramid construction shifts by a century or more, synchronisms with Mesopotamian dynasties or early Aegean cultures may need fresh examination. Even small tweaks can ripple outward, compressing or stretching timelines that textbooks long treated as fixed. For alternative researchers like Graham Hancock, this provides space to argue that fragments of older knowledge may have survived into dynastic times. For conventional archaeologists, it underlines the need to refine methods, expand cross-disciplinary collaboration, and avoid overreaching beyond what new data can actually support. The recalibration story also illustrates how scientific corrections transform narratives. Where earlier chronologies relied almost entirely on textual anchors, lists of rulers, annals, inscriptions, today geochemical data, archaeomagnetic records, and ice cores expose uncertainties we never guessed existed. If mortars or burnt remains point to earlier phases of monument building, then entire stretches of high culture might predate the earliest surviving texts. This would put unprecedented weight on material evidence alone, architecture, astronomy, and engineering choices becoming central guides to history when written names fall away. Of course, skepticism remains, and rightly so. Old wood reuse and stratigraphic contamination are still viable explanations. Without absolute certainty that test fragments date directly to original construction moments, no one can yet declare that pyramid cores predate Khufu definitively. What the renewed calibration does is to tip the discussion from "these samples must be flawed" to "these samples deserve further testing." Already, new laboratory programs in 2025 have aimed to extract ever smaller microsamples, minimizing the chance of contamination, while pairing radiocarbon data with archaeomagnetic signatures in the same strata to strengthen chronological anchors. The wider significance is how fragile the appearance of certainty can be. An entire civilizational framework once felt immovable, pinned to reigning pharaohs. Now improved calibrations reopen questions. For some, this points to continuity, monuments as inheritances modified by successive rulers. For others, it could hint at deeper legacies predating dynastic Egypt altogether. Either way, the secure anchor has shown itself to be adjustable. And when an anchor moves, the ships tied to it drift as well. These refinements highlight a central fact. History is not set forever in stone, but shaped by each round of evidence and correction. For viewers, the hook lies here. If radiocarbon curves shift core monuments backward even slightly, what other mysteries long buried in sand or ice might change when disciplined reanalysis occurs? And if dates move further into the past, who, if anyone, came before the pharaohs we know? The next part of our story takes that question to a new horizon, one where debates no longer rest only on stone and carbon, but on disclosures about technology said to arrive from beyond the Earth itself. Extraterrestrial connections and UAP disclosures. In 2025, the discussion about unidentified aerial phenomena shifted from the margins of conspiracy theory into the language of official reports. Government publications and testimony confirm that defense agencies and contractors hold materials described as unusual for their composition and behavior. Some of these fragments have been studied in classified laboratories to test for exotic properties. Officials did not declare them extraterrestrial. Their provenance remains classified, their origin unresolved, and their significance contested. Still, the very act of acknowledging their existence moved the debate into public record, bridging speculation with data points that could no longer be waved away as rumor alone. That acknowledgement complicates how we read our own past. Cultures across the globe preserve traditions of sky beings descending with knowledge. Sumerian epics describe gods arriving from above bearing gifts of law and tools. In Mesoamerican lore, figures like Quetzalcoatl teach agriculture and mathematics. In Egypt, founding myths attribute geometry and order to deities from beyond. These texts have often been interpreted as metaphor or religious projection. Yet with modern officials describing recovered materials of unexplained origin, the possibility that such traditions framed real encounters becomes a question worth revisiting. Importantly, this is not proof of historical contact. It is a fresh reason to treat ancient accounts with care rather than dismiss them wholesale. The official reports circulated in 2025 carried details that feel strikingly familiar when placed alongside old myths. Fighter pilot videos documented craft moving at abrupt angles and speeds unknown in current aeronautics, apparently ignoring inertia and producing no sonic booms at supersonic velocities. Operators described smooth metallic surfaces, vanishing from sensors only to reappear miles away. These accounts echo ancient language about chariots of fire or luminous wheels in the heavens. The parallel does not establish identity, it suggests resonance between two vocabularies separated by thousands of years. One used the idiom of gods, the other the language of aerospace. Both grapple with phenomena outside familiar frames. One recurring theme in modern and ancient testimony is the manipulation of light. Babylonian records describe radiant discs projecting luminous halos. Contemporary instruments register craft glowing in infrared while leaving no optical heat signature. Both scenarios describe a visibility paradox, objects radiant in some registers, invisible in others. Sound, or silence, is another shared motif. Indigenous narratives frequently describe silent flight, while modern pilots emphasize their shock at observing high-velocity maneuvers without sonic consequence. Such consistencies fuel the debate about whether cultural memory could encode observations of unidentified craft. Skeptics insist a clear distinction remain in place. They note that humans once interpreted comets, auroras, or meteors as omens from gods. Historical observers frequently projected agency and mythic narrative onto natural events they could not otherwise explain. The caution is well-founded. The presence of unusual modern craft, however unexplained, does not verify that ancient accounts recorded extraterrestrial visitors. It simply destabilizes the certainty that such reports must have been imagination alone. A balanced approach keeps both ideas on the table, that myths may reflect awe before natural spectacle, and yet also may encode fragments of real encounters with objects not sourced from recognized human culture. Technical descriptions within official files are equally contested. Some reports reference materials with unexpected atomic structures that exhibit properties beyond standard alloys. Engineers point to precisely arranged lattices, the sort of design associated with advanced fabrication techniques. If such materials are genuine, they defy easy categorization within known metallurgical processes. Here too, the interpretive caution applies. Fragments of unusual composition do not prove extraterrestrial manufacture. They highlight gaps in current understanding and leave room for inquiry. The temptation is to conflate indestructible weapons or divine armor of legend with such materials. The responsible stance is to recognize the similarity in description while maintaining the distance between myth and metallurgical test reports. Together, disclosures, pilot testimony, and material studies weave a narrative thread that many find compelling. Ancient traditions of culture bringers from the sky, sudden leaps in architecture appearing after global cataclysms, and modern admissions of unidentified objects with extraordinary performance all seem to rhyme, yet correlation is not confirmation. Each domain, oral tradition, archaeology, classified technology, demands independent standards of evidence. The conversation gains power not because one domain proves another, but because they circle common motifs strong enough to warrant interdisciplinary scrutiny. For adherents of the ancient astronaut hypothesis, these developments amount to vindication. The suggestion that gods may have been historical visitors has been ridiculed for decades. Now, with agencies openly exploring materials beyond conventional science, the argument is harder to dismiss outright. It is not validation of every claim. It is validation that the topic belongs in serious discussion rather than in ridicule. Alternative researchers find themselves closer to official statements than ever in their lifetimes. Mainstream voices continue to urge restraint. Historians warn that linking myths to UAP without direct corroboration risks collapsing literature into modern speculation. Archaeologists point out the absence of transitional artifacts bridging legend to recovered alloys. Scientists emphasize that unexplained does not mean extraterrestrial. These cautions remain critical. Without them, curiosity transforms too easily into overreach. But alongside caution runs an equally valid question. When new data overlaps with old stories, should scholarship at least reevaluate its categories? Some myths may not only be metaphors, they may be historical memories filtered through the only idioms available. What emerges from this tension is not a closed case but an open dossier. Myths now stand beside official testimony that strange technology exists, studied but not fully explained. The effect is a shift in the burden of consideration. Where once scholars could simply dismiss sky-being stories as religious imagination because no such technology exists, today the category of the unexplained is no longer empty. By acknowledging unknown craft and unusual materials, governments have reopened interpretive space. Within that space, the study of myth acquires renewed importance. The stories we inherited may not provide factual blueprints, but they may hold experiential traces worth analyzing with fresh eyes. For the public, the resonance is immediate. The fusion of myth and disclosure suggests that human history might be entangled with episodes not yet accounted for in textbooks. Some observers argue civilization developed entirely alone. Others suspect moments of external influence punctuating its trajectory. Both positions find echoes in existing data. What matters most is that the framework has widened. The conversation has grown too complex to ignore, bridging myth, science, and modern testimony in a way that reshapes how we ask questions about our origins. And it is exactly here, where the evidence is provocative but incomplete, that resistance becomes most visible. Even as officials confirm unusual materials and pilots recount extraordinary encounters, academic departments often push back hard. Leading archaeologists caution against what they describe as pseudo-history. Historians call for heightened skepticism. Yet engineers and physicists examining anomalies detect measurable effects they cannot dismiss. The resulting clash makes clear that the debate is no longer about whether anomalies exist, but about who gets to interpret them and on what terms. When mainstream archaeology pushes back. If new measurements and anomalies draw attention, the strongest reactions often come from within the halls of established scholarship. This is when the pushback becomes most visible. Mainstream archaeology approaches its subject through a well-defined set of practices: careful excavation, rigorous attention to stratigraphy, and contextual interpretation rooted in reproducible field methods. When claims jump too quickly from remote sensing images or unexpected readings to sweeping revisions of history, archaeologists argue that the necessary intermediate steps, excavation, peer review, and comparative testing, have not yet been done. For them, keeping those standards intact is essential to protecting the credibility of the field. Criticism of alternative theories has been voiced loudly in recent years. In 2022 and 2023, for instance, the Society for American Archaeology released public statements criticizing Graham Hancock's Netflix series Ancient Apocalypse. They argued that the show bypassed peer review, selected evidence to fit a predetermined conclusion, and risked misleading viewers by presenting speculation as though it were settled fact. Commentaries in media outlets like Slate and Courier International echoed these concerns, noting not just the evidentiary gaps but also the cultural implications. Some scholars worried that framing indigenous myths as remnants of an advanced lost civilization ignored or diminished the achievements of the cultures themselves. To many professional archaeologists, that concern is not theoretical. It goes to the heart of how narratives shape public respect for living descendants of ancient peoples. These objections are not only about interpretation, but about methodology. archaeologists stress that discoveries become accepted history only after they survive a particular sequence of steps: field excavation with documented context, laboratory analysis, peer review by independent experts, and replication of results by multiple teams. Remote imaging can highlight anomalies beneath sand or soil, but until trenches are dug and layers confirmed, the anomalies remain leads rather than certified sites. Geophysical surveys can suggest that something unusual is happening inside a monument, but until samples are tested or chambers explored, the findings are speculative. This is why many archaeologists bridle at announcements that leap straight from radar sweeps to claims of missing civilizations. For them, the chain of proof has not been completed. To help audiences follow this, imagine a short checklist. When a claim moves from satellite image to historical revision, mainstream experts typically demand three things. First, independent surveys by separate teams using different instruments. Second, controlled excavation that verifies the presence of cultural material in context. And third, publication in peer-reviewed journals. Without those steps, the claim remains provisional. They argue this is not obstruction, but protection against repeating past mistakes, when false leads once derailed historical study. Yet critics of orthodoxy argue that the defensive instinct sometimes becomes excessive. They note that engineers mapping acoustic resonances or physicists measuring electromagnetic irregularities often publish their findings in technical journals, even if those results unsettle established models of history. When such work is dismissed out of hand, the public hears silence rather than engagement. This fuels suspicion that archaeology is protecting its reputation rather than grappling with new data. Here the conflict is less about whether anomalies exist than about who is willing to interpret them and on what terms. There are examples where hesitance has eventually given way to acceptance. For much of the 20th century, many archaeologists believed humans had only been in the Americas for a few thousand years. Evidence from sites such as Monte Verde in Chile and later discoveries pushed that timeline back tens of thousands of years. What was initially dismissed as impossible eventually became mainstream. This precedent is often cited by those who urge caution against reflexively rejecting new evidence emerging from physics, engineering, or geology. Resistance may preserve rigor, but it can also delay recognition of authentic breakthroughs. The debate also has an institutional side. Academic careers are built on stable chronologies and published interpretations. Collaborative grants, graduate programs, and even national heritage projects often rest on maintaining accepted narratives. If radiocarbon recalibrations or satellite maps challenge those narratives, entire instructional frameworks risk being upended. The instinct is to defend, since the costs of acknowledging large revisions are steep for an established scholar's reputation. By contrast, specialists in other disciplines, engineers, computer scientists, physicists, have little stake in archaeological orthodoxy. For them, anomalies are opportunities, not threats. This misalignment of incentives widens the gap between fields. Cultural factors sharpen these disagreements. Public-facing books and documentaries by alternative writers can attract millions of viewers, dwarfing the audience for academic monographs. While scholars often see this imbalance as frustrating or even dangerous, viewers interpret it differently, as evidence that mainstream voices avoid engaging with new ideas. The criticisms may be valid, but the optics reinforce a story of closed gates. Meanwhile, data continue to circulate, magnetometers charting variations at stone sites, AI flagging patterns in ancient texts that seem to demand attention whether or not archaeologists participate. Still, it would be inaccurate to suggest mainstream archaeology has no reason to be cautious. Their disciplinary norms value careful pace and reproducibility. Critics who want findings recognized overnight often overlook how long legitimation usually takes. Years of excavation logged with meticulous notes, followed by independent replication under strict standards. For example, when Muon tomography revealed an unexplored cavity in the Great Pyramid in 2017, it took years of refinement and cross-checking before the results were widely acknowledged. Archaeologists point to that process as proof that caution is necessary, not obstructionist. As younger scholars rise, the boundaries are beginning to look less rigid. Increasingly, doctoral programs encourage cross-disciplinary training, with students learning to interpret remote sensing data, geophysical surveys, and isotopic analyses alongside traditional excavation. These researchers are more comfortable moving between methods, and many believe the future of historical inquiry depends on collaboration. The tools available in the 2020s, high-resolution satellites, AI pattern recognition, improved dating curves, are too powerful to ignore. The real question is whether archaeology integrates these tools with its traditions or risks being bypassed as other fields pursue them independently. For the public, the contradiction is striking. On one side, archaeological authorities call for restraint, stressing context and peer review. On the other, new data emerge in venues far outside archaeology's journals, showing patterns that appear consistent across continents. As long as these two approaches remain siloed, the dissonance will persist. But if collaboration deepens, it becomes possible to test anomalies against material evidence rather than opinion. That is, after all, the ideal scenario. Not blanket rejection, not unfettered acceptance, but multiple fields cross-examining the same puzzles from different angles. So the most constructive position is not to defend walls or tear them down, but to build bridges between methods. Archaeologists, geophysicists, engineers, and materials scientists working in concert could either confirm or rule out anomalies with far more certainty. And when a claim survives that scrutiny, it becomes much harder to dismiss. The real prize is not winning a debate, but gaining clarity about the past. The stakes extend beyond academic quarrels. If established chronologies can be adjusted by new evidence, entire stories of human beginnings may need rewriting. And when scholars clash over control of those stories, the losses are not personal. They shape how the public understands its shared history. That shared story, fragile as it is, may itself be influenced by memories of events that scarred multiple cultures at once. Which raises a deeper puzzle. Why do civilizations across the globe preserve such vivid accounts of destruction, flood, fire, falling stars, that echo each other despite vast distances? The question now is whether these memories hint at more than myth, and what recent scientific findings suggest about the disasters our ancestors may have lived through. A shared legacy of catastrophe. Why do so many societies, separated by oceans and millennia, preserve stories of overwhelming disaster? From Mesopotamian floods to Andean visions of fire from the sky, and from Native American tales of a burning earth to Asian stories of darkened heavens, the theme of sudden destruction repeats in striking ways. Generations of scholars interpreted these traditions as moral allegories or symbolic meditations on nature. But the scale and consistency of the parallels suggest that these traditions may be pointing toward shared experiences with environmental crises that marked human memory deeply. Recent scientific work has added new tension to this question. In 2025, analyses of Greenland ice cores revealed microscopic diamonds embedded in layers dated to roughly 12,800 years ago, the onset of the geological episode known as the Younger Dryas. Microdiamonds are not normally present in glacial ice. They typically form under extraordinary heat and pressure, conditions associated with meteoric impact or other high-energy events. Alongside this, researchers have identified a thin layer of platinum in some North American and European sites and charcoal-rich sediment consistent with continent-wide wildfires. Combined, these clues have fueled the Younger Dryas impact hypothesis, the suggestion that fragments of a disintegrating comet or asteroid struck the planet, sparking climate chaos, mass extinctions, and upheaval for early human groups. The timing is crucial. Around 12,800 years ago, the climate underwent one of its most abrupt shifts. The world, transitioning out of the last ice age into a warmer era, was suddenly plunged back into near-glacial conditions. Megafauna like mammoths, giant sloths, and saber-toothed cats disappeared from much of their range. Human cultures grappling with early farming or sedentarism saw their progress interrupted. To some researchers, the evidence points to an external shock that triggered cascading effects strong enough to rewrite ecosystems and redirect the trajectory of civilization itself. But it is important to recognize that the impact hypothesis remains sharply contested. Many geologists and archaeologists argue that established mechanisms, such as meltwater pulses from collapsing ice sheets that disrupted ocean currents, adequately explain the Younger Dryas cooling without invoking a cosmic strike. Critics highlight the absence of a single large impact crater dated to the precise period. Advocates counter that multiple smaller airbursts over ice sheets could leave signals in sediments without one obvious scar. Others propose solar outbursts as an alternative trigger, an extreme burst of solar radiation capable of setting wildfires, altering atmospheric chemistry, and producing signatures like elevated nitrates in ice layers. Each explanation attempts to interpret the same anomalies: microdiamonds, wildfire deposits, and rapid cooling, but no single theory has convinced the entire scientific community. The role of myth becomes particularly intriguing here. Flood narratives from Mesopotamia and the Mediterranean describe rising waters overwhelming cities. In the Americas, oral histories speak of fire from above, animals perishing, and skies turned unrecognizable. In Asia, some traditions describe darkness and societal collapse, followed by renewal. These stories could represent cultural memory of distinct local phenomena. But taken together and anchored to physical evidence that suggests global disruption at the same horizon, they might also reflect widespread human attempts to process an event that touched many regions at once. Interpreting myth as cultural memory has to be done carefully. Oral traditions are shaped by retelling, adaptation, and symbolic layering. Skeptics argue that it is unlikely for stories to preserve clear detail over more than 12,000 years, yet there are examples that complicate this view. Indigenous Australian stories, for instance, encode descriptions of coastlines that were submerged roughly 10,000 years ago at the close of the Ice Age, narratives remarkably accurate when compared against modern reconstructions. If such long-term retention is possible, then catastrophe myths may also preserve kernels of real events, albeit transformed by generations of metaphor and ritual retelling. Supporters of the impact hypothesis point to the convergence of multiple strands: high-energy proxies in geological layers, sudden climate reversal evidenced in ice and tree rings, and the cross-cultural echo of catastrophe stories. They argue this triangulation makes it harder to dismiss the notion of a shared global trauma. Critics counter that the same data could still be explained through more conventional processes, and storytelling traditions do not amount to direct eyewitness evidence. The debate remains unresolved, with growing datasets but no universal consent. The implications, if catastrophic interpretations are correct, are significant. Human communities at the time were experimenting with structures, early crops, and patterned ritual activities. A sudden climatic crisis could have erased much of this progress, scattering survivors and extinguishing fledgling centers. What later looked like abrupt leaps in knowledge, sites like Göbekli Tepe appearing with remarkable sophistication, may instead represent a recovery phase, with survivors carrying fragments of older traditions forward after the disruption. In this reading, myths of lone culture bringers or divine survivors guiding rebuilding efforts become less allegorical invention and more mnemonic devices protecting precious fragments of memory after radical upheaval. Scientific advances are now narrowing the window of uncertainty. Ice core and sediment data can pinpoint events to seasonal or even annual resolution. Ocean cores reveal sudden influxes of scorched terrestrial material flushed into seas around the same time. Tree ring sequences chronicle years of hindered growth consistent with sunlight reduction. Each dataset adds layers of precision, though interpretation still varies. The evidence establishes a moment of exceptional stress on the global environment. Exactly what triggered it, impact, solar burst, or terrestrial dynamics, remains a matter of vigorous inquiry. Rather than imposing certainty, the strongest conclusion is that something extraordinary did occur around 12,800 years ago, leaving both environmental scars in Earth's record and cultural scars in humanity's shared imagination. Myths may not be literal eyewitness reports, but they could be narrative structures developed to preserve lessons from catastrophe. Fire, flood, and celestial upheaval are recurring languages to encode memory of trauma. Whether or not the details reflect a single precise event, what these stories show is a species straining to safeguard messages for descendants about fragility and resilience. The greatest challenge ahead is weaving physical science, archaeology, and cultural testimony into one framework without overreach. Myths cannot substitute for data, and data alone does not explain why stories recur with such striking resonance. It is at the intersection that the richest questions emerge. Are we glimpsing evidence of a single shared survival memory? Or are we witnessing the universal human impulse to build parables for cycles of destruction and renewal? Both possibilities remain alive. This duality leads to a provocative reflection. If environmental crises shape myths of cosmic fire and flood, might they also explain why so many cultures reset their knowledge base, preserving fragments that reappear in architecture, calculation, or ritual thousands of years later? If so, could such a catastrophe explain abrupt cultural resets, and might myths be memory traces of that survival? We'll explore how that idea connects to architecture and text next. Technology rediscovered, lessons from the past. Are we inventing the future from scratch, or are we recovering fragments forgotten by time? This question hangs in the air when engineers and archaeologists use modern tools to revisit ancient structures. In 2025, several research teams applied acoustic and electromagnetic simulations to three-dimensional models of the pyramids. Some of these reconstructions suggested that the monuments could sustain resonant frequencies when sound is introduced into their chambers. Rather than noise being absorbed and lost in the stone, waves seem to linger, circulating through narrow passages and amplifying in larger cavities. The results were striking enough to attract attention. certain frequencies clustered around the natural range of the human voice. That suggests chants or instruments played during ritual were not incidental but might have activated resonant effects. Inside such chambers, the experience would be overwhelming, voices magnified, air vibrating, and architectural stone itself seeming to hum. To the participant, that might have conveyed an impression of profound, even divine presence. To modern engineers, it demonstrated an acoustic property more controlled than accident alone would imply. Yet it is important to stress that these are computer and laboratory reconstructions. They show what is possible, not what has definitively been proven on-site in ancient contexts. Similar modeling of electromagnetic fields added another layer. When researchers projected simulations against pyramidal geometry, the stone masses appeared to shape and focus currents. Concentrations were strongest in the subterranean chamber and along shafts. Limestone, especially when it contains quartz or conductive minerals, can interact subtly with ambient fields. Some suggested this material choice was deliberate, serving both symbolic and practical purposes. But others reminded that geological availability explains the use of limestone just as well, and any emergent electrical behavior could have been coincidental. The key point is that experimental reconstructions hint at effects, though proving deliberate intent lies beyond current evidence. This sort of speculative environment is where balance is needed. Anomalous readings and simulations are valuable but not conclusive. For rigor, results must be tested against field data gathered inside the actual structures, with reproducible instruments, contextual archaeological analysis, and publication in peer-reviewed forums. Without this chain, interpretations remain hypotheses. Presenting them responsibly means labeling them as possibilities under investigation, rather than confirmed attributes of ancient engineering. Scholars insist on this distinction not to diminish curiosity, but to protect against misinterpretation. Claims about pyramids functioning as devices cannot be confirmed until ground truthing completes the picture. Even with those cautions, the experiential dimension raises questions. Hancock has described conversations with locals and ritual custodians who spoke of sound as a living force within ancient spaces. In personal testimonies, some recalled chants resonating so strongly in chambers that participants felt transported or overwhelmed. Accounts like these cannot prove ancient builders intended specific acoustic effects, but they do illustrate how architecture and ritual combine to create striking psychological experiences. Seen from this perspective, simulations of resonance help explain why spiritual ceremonies developed the reputations they did, even if the builders themselves describe the phenomena in terms of divinity rather than physics. The possibility that fragments of practical knowledge survived disaster and were preserved in symbolic garb remains part of the debate. If a culture recovering from upheaval did not explain resonance in mathematical terms, it may instead have encoded the outcome in myth, voices of gods or walls that sing. Ritual repetition then transmitted the practice even while the technical rationale faded. By the time modern science detects resonance inside stone chambers or electromagnetic concentrations in limestone, we may be seeing echoes of principles known experientially, not theoretically. Such echoes would not make the pyramids machines, but sites where nature's properties were amplified in ways meaningful to those who built and used them. Modern parallels add to the intrigue. Contemporary research in acoustic therapy examines how frequencies influence human physiology and states of consciousness. Brainwave patterns altered under certain tones are studied in controlled conditions. Digital reconstructions of temples like Abu Simbel suggest that chants at specific intervals match frequency bands associated with trance or meditation. Were ancient priests guiding spiritual journeys, or were they facilitating neurological states through sound without labeling it as such? Electricity and resonance within stone could have generated impressions of fire or power in darkened passages, phenomena interpreted as mystical but perhaps grounded in material effects. The notion here is not that Egyptians or their predecessors ran laboratories in the modern sense. Rather, that cultures observed effects, wove them into ritual, and transmitted them through symbolic language. What universities today divide into religion and science may once have been experienced as a single continuum. Over centuries, explanation hardened into ritual while observation survived as story. When modern instruments peel back the ritual shell, they occasionally reveal repeatable physical effects beneath. That does not diminish the sacred dimension. It shows how knowledge and faith may have coexisted within the same monumental stone. Skeptics urge restraint. Computer models reveal what structures can do under controlled inputs, but ancient use may have been more variable. Singing in a chamber could resonate, but whether it consistently sustains standing waves requires demonstration in real conditions. Similarly, electromagnetic clustering visible in simulations must be measured on site, separated from modern interference, and analyzed in geological context. That work is ongoing. Without it, theories about energy devices remain provisional. The convergence of multiple consistent results across reconstructions argues for real effects, but whether those effects were intentionally engineered or incidental remains undecided. History suggests another perspective: continuity through partial memory. Surviving a catastrophe, human groups might preserve the outcomes of knowledge without retaining equations or technical theory. Rituals producing powerful experiences would be repeated. Over centuries, their symbolic and spiritual justifications would outlast the physical explanations. In this reading, modern science does not uncover forgotten devices, but recognizes that practices embedded in ritual sometimes harness natural phenomena in systematic ways. Discovery then appears less like invention and more like recollection. Humility follows. Scientific narratives often portray history as a steady climb, but the evidence suggests something more layered. Knowledge seems to spiral, preserved partially, lost, and later re-encountered. Resonance once experienced in stone becomes rediscovered as acoustic therapy. Alignments once read as divine correspondences become rediscovered as astronomy. Geometry once tied to ritual maps echoes mathematical principles. Each rediscovery is both progress and memory, layered together. The lesson extends to today. If modeling reveals vibrational or energetic patterns in monuments, those results hint at principles still dormant in cultural memory. Not every alignment is symbolic alone, not every chant is pure myth. Some may reflect experiential interaction with natural laws, carried through time and language and ritual rather than in laboratory records. Seeing that possibility shifts how we interpret continuity between past and present. It encourages science to regard myth not as superstition, but as a container for kernels of practical truth. When sound pulses echo through reconstructed chambers, they remind us that ancient spaces might have been designed to heighten sensation. When simulations show electromagnetic clustering around chosen stone, they remind us that material choices matter. When myths produce numerical cycles that match celestial motions, they remind us that oral traditions can carry empirical observations. Each instance points to the same pattern. Fragments of practice survive catastrophe and later resurface as rediscovery. Humanity's progress, then, may be as much about remembering as inventing. Perhaps that is why these questions still resonate so strongly today. Our tools demonstrate properties our ancestors experienced, even if they name them differently. The walls of stone echo with layered meanings, spiritual, symbolic, practical, all at once. Whether we treat those echoes as devices or experiences, they speak to continuity across vast stretches of time. And so the larger issue is not just what ancient builders achieved, but what their work suggests about us. If traces of knowledge can survive in stone, myth, and ritual, then the future of discovery may rest less on pure innovation than on recovering scattered memory. That recognition leads naturally to the final question: what does this imply about humanity's place in history, and whether we truly stand as the first to build what we call advanced civilization? Across all of this, 3 points stand out. First, the discoveries of 2025 are accelerating debate and yielding intriguing but still preliminary data. Second, many of the claims remain controversial and await verification through excavation, laboratory analysis, and cross-disciplinary review. Third, the most thought-provoking possibility is that fragments of older knowledge may have been preserved in ritual, architecture, and story rather than lost entirely. Be skeptical, be curious, demand data, insist on method, but do not ignore patterns that appear across disciplines. If one of these findings surprised you, share which one in the comments. Tell Shiloh, Göbekli Tepe, or the Giza radar anomalies, and subscribe if you want measured follow-ups as more evidence comes forward. Throughout this episode, you've heard both bold claims and the objections against them. This channel will continue to track independent confirmations, so the conversation stays anchored in evidence rather than assumption.